Hello, everybody. It's Larry. It's Weekly Contest 167. Again, always as usual, wish me luck. Had a terrible contest this morning, but it wasn't that bad. It was just mental mistakes. So I'm going to try to actively slow down a little bit and, make sure I get the edge cases. So that's my big thing. Hit the like button, hit the subscribe button, hit whatever button you like. And you could watch my last video on the YouTubes. Hopefully, this one turns out a little better. I have 8 seconds, so I will talk to you at the end of the contest. But the other head will talk to you pretty soon, though. I hope so. That's how this works. Cool, cool, cool. Yeah, let's get started. Problem one. So I saw a linked list. I saw something about converting binary numbers. I looked at the examples, and I knew immediately that how to do it. I just wanted to make sure that I get the order right, so it's most significant bit first or last and stuff like that. I was thinking about the edge cases, but well, not really. I think I knew how to do it pretty much right off the bat. Not that much. This is pretty standard, so do I forget to multiply by 2, which I do. I think I am now about 20 something seconds in. And I probably would have been confident enough to submit this, to be honest. But recently I've had some, strain of just carelessness on my part and mental mistakes. So I'm just trying to be slightly better and just at least one dose code. It looks okay. I still feel confident about it, so I'm going to submit it. And I actually finished this one in 1 minute and 4 seconds. So that was pretty good. A good start. Sequential digits. So a little bit of a disclaimer is that I did code force for practice earlier today. And I think the contest number is 606. But there was a very similar problem to it where it's on that one is repeating digits, I think. It's either that or maybe it's just another problem set. But I did a very familiar problem today. And this one is obviously a little different in that, it's sequential digits instead of repeating digits. But because of that experience, the idea is still the same, which is that you could generate it one digit at a time and then just check to see if it's low or high, because there's going to only be like 10 times like log n numbers to check. So pretty straightforward. You just keep on adding numbers and you just have to add a few things to track. I think I was a little bit deliberately slow on this one because, as I said, this contest, my goal is to be very super careful, and not because I think recently I've been trying to go for the high score a little bit too much and just trying to be too fast. But I made a lot of silly mistakes. But yeah. But I thought this was mostly right. Though actually this is wrong. Well, first of all, you have to return the numbers, not just the count. And I was like, oh wait, that's just wrong. And you have to sort it, but I also knew that there were going to be that many digits or numbers in the answer, so I could just sort it afterwards. I think I just double checked to see if I needed to sort it. But yeah, and it gives me a complaint, which is good in Python 3 with the type hints. Something that in previous Python I maybe have not noticed per se. But yeah, and I saw 100 and clearly that's bad. So I'm trying to figure out why. And then I was also thinking about single digits at the same time. I forget, I don't remember what number triggered it, but I knew immediately by one of the numbers on the example case, I was like, oh, I think it was 900, where I was like, oh, that doesn't make sense. So then I was like, I have to make sure that y is less than 10, or like from 1 to 9, right? So that should be okay. I think here, in theory, if I was confident, I would have been okay to submit about 3 minutes in, 3.5 minutes. That's about par for the faster people. But again, today, like I said, I'm not confident at all. Recently, I've made a lot of stupid mistakes. And one of them that oh yeah, so that was another one. So I'm really good that I double checked. I would have double checked more anyway. I think the one thing that I did want to double check is the the single digit numbers, even though that's not in the response. I even used the wrong test case here, and I
1 digit.
Yeah, but I'm very slow here, very deliberate, just to make sure that I get everything right. It's intentional. I mean, I do a lot of testing. I actually even checked for the single digit case because my code actually doesn't handle it. But looking at the constraints, like I think I saw the constraint after I typed it. At that point, I was like, I might as well keep it in, so it's not a big deal. But and it doesn't really affect running time or anything like that. But I think at this point, I'm just also like not taking anything for granted a little bit. So definitely a little bit deliberately slow on a contest where every minute is ridiculous.
Oh, it has to be at least 10. Well, either way, I guess.
Yeah. So this one, I actually don't think I actually go over this a little bit in the postmortem. I don't think I solved this optimally, but I actually thought I had a cool way. I think the first thing I needed to do was calculate what's it called, prefix sums or partial sums. And I knew that I need to do that, immediately. And then I was going to worry about how to do to find the biggest square later. And I did come up with kind of a cute solution, but it ended up being a little bit of. I mean, I have another solution afterwards. But yeah, right now I'm just thinking about how to do it. But I knew that I just do the partial sums, and I did that here. Because n times m or n is less than 300, so that means n cube algorithms are not going to be good enough, right? So that's how I think about this one. But after doing the partial sums, which I haven't done in a while, so I'm like a little slow here. But and I actually did this in the wrong order, I think, for partial sums. Or like I tried to be a little bit too smart. I think I wasn't on the wrong order, but this is okay. And then so the idea that I came up with, well, first of all, I think at this point I wasn't exactly there at the idea yet. But the idea I was doing is that okay, I think there's a binary search, because okay, given a corner, given a x and a y being a corner of the square, the bigger the size of the square, because there are no negative numbers, that's the big one. Because there are no negative numbers, the bigger the square, the more likely it's going to go over the threshold, right? So it's just going to be bigger, 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 and then threshold, and then you have to stop. And that is just like a very straightforward binary search recurrence, or property rather. So as a result, I yeah, as a result, I did essentially code that up. But I think another kind of cool idea that I had after the contest, and you'll hear me talk about it in the postmortem, but I might as well tell you now, so you could fast forward if you really like. But is that you can actually, because you only have to return the biggest square. There's actually, you could walk the ladder in a way, and what that means is that if you keep the current best, meaning, okay, let's say your current best is a 3 by 3 square, then you actually never have to check anything smaller than 3 by 3, right? So in that case, you only have to check, check to see if you can make a 4 square, and then a 5 square, and so forth. And if you can't, then just go in the next square, and so forth. And because of that, you only check each of the k amortized once, right? Meaning, Yeah, so because effective, you get this n squared plus k, which is n squared again. So it's effectively an n squared algorithm. But I didn't do that during the contest, as you can see. And if I had, and I don't think that's an easy occurrence to come up. Though maybe people have more experience of it, so that's why people are so fast. But because of that, I am a little bit slow. Because how much time did I spent 23 minutes in it? So that means I spent another 10 minutes on this, or 11, 12 minutes on this. A lot of it just debug, or not a lot, but some of it debugging because I had an off by one as well, which I was thinking about, but I just took some time and unfortunate to fix. But yeah, which is sometimes sad. But yeah, I think walking the ladder thing is a beautiful algorithm for this, and I think I just didn't really occur to me. Yeah, and seeing how 400 people solved it, maybe either there's an even easier way, or that's a very standard algorithm that I haven't touched in a while. Um, but I'm glad that I still solved this, even though it took another 10 minutes. But yeah, but here I have a helper function of that just helps me do the binary search. Um, so this goes on for quite a bit more. I think I do some debugging here, but like the binary search is pretty straightforward. I just wanted to make sure I get it right. Out here, if you saw my earlier video from earlier today, one of my problems, one of the problems I ran out of time, like I got time limited exceeded because of function calls. So that's why I was very hesitant to put in a function call. But for this particular one, it would have been a little bit messy to write. So I actually end up refactoring this in a couple of minutes. Um, and kind of the cool thing with kind of the stepping the ladder thing is that you can actually use that with the binary search as well, right? So that it could actually get you down, but that's just constants, so I wouldn't worry about it. But that would be a cool kind of trick for sure. And as usual, I'm for binary search, I'm very not confident about off by ones. I do this little janky thing, to be honest. But here I was like, I have to copy and paste this and then make sure that I get everything right. So I just end up refactoring this. I'm only 12 minutes in. What did I spend another 10 minutes on? I guess off by ones. So I do have an off by one here that see if you could spot it. I was thinking about it while programming it, but I think at this point I was just so I wouldn't say focused, maybe tunnel visioned on kind of just getting it out that yeah, that I really just missed the reason why. And to be honest, when I submitted, I wasn't that confident about it, even though, yeah, if I had, yeah, more mental or something, I would have got the other one. Compiler error because I have periods. But this is mostly it, and I spent about 10 minutes debugging this, which is kind of really sad, actually. I didn't realize I spent that long debugging it. I ended up spending about 18 minutes on this problem, which I guess it's not that bad considering I don't think this is one of the problems I haven't seen before. So I think here I was thinking about whether this off by one, but I think I think I made a mental note to be like, let's just test examples and see if it's okay. If it's not, then we'll fix it. But then I forgot about it. So yeah, definitely focus and yeah. But for me, like I remember thinking this was not an easy problem for me, so I don't feel so bad about it. Except for the off by one, which I could have probably done better on. then I would have submitted about now-ish, which is 14 minutes in, versus about 23 minutes, which is when I actually did submit it. And if I did save about even just 8 minutes, I would have been top 50. Would have been okay. Yeah, that was the big one, but just not check, because it always returns 1. But the real issue is because I had an off by 1. If I didn't have an off by 1, I think that would have the binary search would have just returned 0. And here, luckily, I did have a wrong answer on the examples, so I think I was writing it down on a paper just to be like, okay, does this make sense? No, not really. Or like the way I'm doing it. So then I went to do a lot of debugging things like printing the screen out and stuff like this. So nothing. Point F there. I've been doing a lot of C++ recently as well, so some stuff is a little I don't know, just not quite there. Here I was like trying to find out why. I was like, that doesn't make any sense. Just in general, like why wouldn't it be 3? And then I finally print out the DPOA. Oh, and that's the well. Okay, so I was a little wrong on that off by 1. I forgot about this other bug that I have, which I just did the partial sum wrong because it was accumulating too much. I was like, oh, that's not right at all. So this took me a couple of minutes to fix, which is fair. And I haven't done partial sums in a while. I vaguely remember it, which is the worst idea ever because you don't prove to yourself from scratch. You just write for loops. But this is a easy fix, even if it took a couple of minutes. Like mentally, I was like, ah, after I get this is okay. But though I don't look it right now. Now that I look at my face, I look very, very, I don't know. But yeah, I think at this point, after well, I'm just trying to I'm trying to visualize it a little bit more than I should have. I probably should know this a little more. But I was like, I think for me, I was just trying to convince whether if I just add it afterwards, is it okay? Or do I have to like do some reverse of ordering or something like that? But it seems like it's okay. So I was just debugging this very slowly on something that I haven't done in a long time, maybe a couple of years, which is no excuse, but yeah, after that, I'm just trying to see if I have an off by 1 somewhere. I was trying to see why that was not working. think I looked at the recurrence a little bit afterwards, but I mean, I knew I was getting that index. I was just seeing whether that works, and then it's like maybe I'm a little more confident. But I was getting 3110, which didn't make sense. So maybe I'm still a little bit weird somewhere. It's like the head -1 was a little bit of a, I don't know, a little bit of a hack trying to get it right. I'm like, how do I change this? A lot of time was spent. I was trying to see, look at the second problem specifically, or second examples, and try to see why it was getting just once. I think that's what Leetcode, I feel like it's good for practicing for me anyway, is kind of, it forces me to do things correctly and quickly, right? Like, I think time is always important in stuff like this, and try my best. So yeah. But yeah, if I finally caught the error, because I think I was finally like thinking about like if I draw the DP in my head, like how do you get that thing? Well, I stopped by like doing a 1 square, it didn't make sense. So after that, I was like, okay, that looks right except for the head. To be honest, at this point, I wasn't super confident yet, just because I've had a lot of weird errors on this one. But I was like, okay, it looks as good as it's gonna maybe get. Let's run it one last time and then submit it. I think I actually, well, I was like, might as well test some more test cases on like small squares, but I think by the time I submitted, I'm still not super confident, just because there's been a lot of stupid mistakes. But when I got accepted, I'm happy as usual. Shortest path in a grid with obstacles. I think I've seen variations of this where there's and I think I knew how to do this roughly immediately, which is kind of sad that it took me about 12 minutes to go then. And the reason I'll kind of explain in a quick moment, but yeah, the key thing to note is that k is up to 40 squared. So I think I pulled up a calculator just to see what's 40 to the fourth or something like that. It looked fast enough, so I was like, okay, or small enough that we could probably do it. So yeah, in terms of the number of worst case states, and I think actually my first thought was actually breadth first search, but I think I did a similar problem recently where it was dice trip because it wasn't always relaxing the lowest thing. because it matters. I think it's still okay as long as you no, because I think in this case actually you don't need dice tray now that I think about it. But I think I was just worried a little bit because this one there no because every move costs something, so you would have been okay with. So maybe I could have saved a couple of minutes, but especially since I spent yeah, and here I was like, do I need dice tray? I wasn't sure. Um, and using a heap as a response. I think now that I think about it, I actually don't need it. I probably could have done a regular queue, and that would have saved me a few minutes. Not because of coding. I think coding is actually I coded pretty much the same way. The only difference is that, and you'll see this in a quick minute, which is that in Python, which is why people are able to solve this problem in like 3-4 minutes, because I would have the problem in not it's not a problem. It's just different for me. Is that in Python a heap is min. It's a min heap versus max heap. So I used the API wrong, and that's on me. And if I used the breadth first search, this would have been straightforward, and I don't think it would have been. And I would have been done about like I mean, or if I just knew it was min heap, right? Is it? I would have been done much quicker, maybe like 8 minutes quicker. So I think effectively, if I do the hand wavy math, which but it's better than the alternative of me getting them wrong. But if I had thrown away like 15 minutes, I would have been top 25 or something like that, which is always a good go. Obviously, that didn't happen. I need to get a little bit, you know, it's okay. I deliberately tried to be slower this round just to make sure that I focus on correctness. I've been focusing on speed too much lately, so I don't feel that bad about it. But these are the things that as a learning lesson, I'm just figuring out try to what to do. But yeah, but I think I actually spent. I mean this one I had a very clean solution, minus the fact that it takes me another. So I think like I spent 5-6 minutes debugging the fact that it's a min heap versus max heap, but that's effectively the problem. So I'm gonna leave you with kind of the Larry's inner dots and his beautiful face. uh, and yeah, I'll see you on the flip.
Min Q again. Oh man. I don't know how long that took, but 9 minutes for top people. 185th. Should have gone down faster. I just got stuck on a Q thing. I spent a long time on C actually, but not gonna feel that bad about it. Finally got a little bit rid of. Finally didn't make any mistakes. I think that's all you can ask for. Didn't make a lot of mistakes lately, so it's good to know. Finished 69th-ish, give or take. Ooh, 2 more seconds, and it would have been maybe a little bit earlier. But yeah, let's take a look at what I did. I mean, I actually don't remember that much. I mean, the first two went by pretty quickly. I definitely took my time a little bit this time because recently I've been just careless. And again, Python. I guess I'll get into it. Let me go over the problems real quick. Oh, yeah, I definitely did this maybe the cool way, but maybe there's a easier n square. Okay, let's go with it. Convert binary number to linked list, or linked list to an integer. I mean, this is straightforward. Actually was pretty confident, but I wanted to double check considering that I've been kind of making silly mistakes. So at least I tested all this stuff, and it still only took me a minute. So yeah, pretty happy about that. And Python makes that easy for you. Not gonna go over that much. So sequential digits. I actually did something similar on in Codeforce, just the other contest. So I was very kind of already knew how to do it, though I still took a bit of time. I mean, the funny thing is now I went the other way where I added this thing which doesn't show up if it's less than 10, which looking at the constraints, it wouldn't have mattered. But it's still nice to kind of be confirmed about it. I think I caught this mistake by double checking because I think I was concatenating like 9 and 10, and then it added up to some weird number as a result. But otherwise, straightforward. And because there could only be a limited amount of these, so you can just brute force generate them in a good way. So I did it in a couple of minutes. Probably could have done faster, but I think I was deliberate about being slow. Maximum size of a square. I mean, maybe there's a more direct dynamic programming that, yeah, maybe you could go back and actually you probably go back and, now that I think about it, you could probably you know, generate the partial sums and then just dynamic programming on that based off the width. Because you know that it's almost like a sliding window type thing, which, yeah, will be n square. Is it? I don't know. But what I did is kind of cool. I mean, I would do say so. Maybe it's unnecessary to be honest, but I think it's kind of cool. I did an n square log n algorithm where I did a binary search, noting that you have the partial sums. Your diagonals will. So I mean, I'm skipping ahead a little bit. With partial sums, you could figure out for a given size, you can figure out the sum of that square very quickly. And the binary search is just to see if you go under the threshold. So that's what I did. I think maybe there's an n square, maybe even n cube algorithm that went fast. I mean, n cube is 27 million, so maybe that's probably a little too slow actually. But and maybe there's something about that that you could play around with. But yeah, I didn't really. I thought I did what I was doing was right, but clearly it got in 4 minutes. Definitely there was a more simple approach. But like I said, I'm taking it more deliberately this time. So yeah. And I show this grid, and I mean,
I think this is pretty standard. Just look at the states. I'm actually a little sad that this took me 12 minutes, but I have to go into the logs and kind of see how long I take. And the commentary you'll point it out a little bit, which is that I mean I got this pretty quick and pretty immediately, but I just got the because in Python the heap is min heap instead of max heap, so that's why I don't know how long I spent, like 2-3 minutes. So it's not a big deal, but 2-3 minutes would have put me maybe close to top 50 if I was, depending on how fast I was. So yeah, I mean overall, probably still slower than I would like per se, but it's a lot of it is intentional. Oh, I didn't explain this problem, but the big thing about this problem is that m times n times m, or m squared times n squared, which is k. So m times n times k is only 40 to the fourth, which is small enough for you to just do a Dijkstra's algorithm on the quickest, with your dimension being your grids and the number of obstacles you use. So in that sense, it feels like a dynamic programming, and probably there's a dynamic programming, but yeah, but that's how I did it. Because dynamic program maybe n to the fourth, but here, is it? No, I mean you could probably do no. Dynamic program is probably m times n times k. So I guess that's m to the fourth. But the way I did it is, yeah, just doing Dijkstra's on those dates, and that's good enough. Should have gone faster, but I got the heap a little bit off. But yeah, well, I mean, it's good to get it. The funny thing is, I actually finished this problem set about the same time as I did the last problem set, except for that I had five submission errors. But this one I had a clean submission error, so I feel good about it. I mean, obviously, 10 minutes would have been really impressive, but I spent too much on C. I think in the code review that you'll watch in a couple of minutes, I'll see how people did it, and then I'll see my reaction. But this one I probably could have done faster. I mean, definitely should have done faster. People done it in 2-3 minutes because it is pretty straightforward. I spent too much time debugging the queue until like I think I put a lot of debug statements in different places. If I had like a debugger, I would probably see this immediately. Can I? Yeah, how about no on submission? But yeah, but if I had a debugger, then I would have seen that it was a min heap, and then I knew how I had to do it. I mean, I mostly did it right. So that's still learning your tools, learning Python. Python has a little quirks, and that cost me a couple of minutes, but that's fine. I mean, I'm just glad to kind of be consistent for once. So yeah, right. See you. I mean, you'll see me right afterwards. So. Looking back at this problem, just to kind of add a little bit more, looking back at this problem, problem B, I think there's actually a clever thing that you can do, and I haven't done it yet, which, I mean, I did a binary search, but you can note that you only have to return the square sizes. So actually, you could, well, one is you could start at your current best and then keep on going up, kind of like walking a ladder. And in that case, it's always going to be O of n. It's going to be O of n plus k or something like that. Because, oh sorry, O of n squared, or m times n plus k, because you're only going to calculate each of the best square at most once, and that will allow you to get that bound. That's way easier to code up, because that's just that's still just twofold. If you check, and if it's better than your current best, then you just increment it and check again, and so forth, right? And then you don't have to and then you don't have to check any squares smaller than that. So that's actually pretty cool, and that's something that would have been way easier to code than my binary search. I couldn't prove it, and and that's one problem with these shorter contests, is that it's harder to kind of think about those things, because you're rushing all the time. But maybe that's not how people did it. Maybe they would just do it another way. So yeah, code review up right now. Hey, yeah, just doing the usual code review.
ranking keeps on jumping a little bit, but I think I'm 69 out of like 5,500 or something like that. I don't know why. I think they have to merge some servers or something like that. But yeah, the first one is easy. Let's upload it. I mean, yeah, this should be straightforward. I feel like I could have done it faster, even, but this is pretty much my code. So yeah, don't really. When you finish in a minute, I feel like maybe I don't have to. I don't have that much to learn. But the second one is the generating digit again. I imagine most of it is the same way. But yeah, yeah. Some people did explicit on the 9, which I of an explicit second folder, which I think that makes sense actually for this problem. So that would have been a little bit clearer in how you want to do it. And depth of search was actually how I thought about it. Really impressed with doing 3 minutes, but not too big of a deal. Yeah. And then problem 3 is the one that I want to learn, so let's see. Yeah, so the cumulative sum is like backwards, this code, but yeah, so this, oh, that makes sense actually. It's just that I didn't do the subtracting part from the overcounting because you wanted to, because given a rectangle, you want to add the previous row and then you want to add the previous column and then you want to subtract the overlap, which I did in another place, but I didn't do it here, which was what cost me a couple of minutes. But here, yeah, I mean, I think this is essentially the idea that I was talking about, where instead of counting by the so this is like more n to the cube. So maybe n cube is easy enough to do in another language. I was a little well, this is at least clever. I mean, it's the same way in that it just counts from the max. So it does, I don't know, but still closer to n cube. So I don't know. Maybe that's fast enough for the example cases because I definitely did not do it this way. Clearly, actually, this is actually what I did the binary search. So feel okay about that. Let's see what anyways did. This is actually the algorithm that I was talking about with respect to walking the ladder. So okay, got that pretty fast though. People are pretty fast about it. I mean, I wish I was able to do the binary search in 10 minutes. I don't know who did it again, but what the, I don't know what that SQR is. Yeah, again, I guess it's, I don't know. I mean, I guess that's fast enough, which it's a little sad for me because I spent a lot of time writing that binary search and also debugging it. Though I ultimately also had it off by 1, so it's okay. And then the last one was the, I mean, I expect this to just be a straight breadth first search. Actually, at the time, I wasn't sure, so I figured I'd just do it with dice sure. But breadth first search works, and also clearly, people have no issues typing breadth first search in 5 minutes. It is pretty straightforward, and there was really nothing weird about it, to be honest, which is a little like I think this is a very standard hard problem. So, or like standard in the sense that like if you're a competitive programmer, then you've probably seen something very similar. So so I think people just did it that way, and I probably should have or could have, but I did it with the I did it. Well, I just spent too much time on the queues, so it is what it is. But overall, not a bad contest. Not a good. I mean, yeah, a good bounce back from my previous contest. So yeah, and I finished 69 out of 5,000. I don't know. Sometimes they take the other server off or something, but yeah, well, you can bounce back, and that's great. So I'm really happy with that. Anyway, see y'all in a bit.
Oh yeah. See you next week, next contest. But hit like and subscribe and all that stuff. Whatever. Bye.